before we go into answering how to run databases on Kubernetes, I think we need to define a couple of the use cases of why one might want to run databases on Kubernetes. Off the top of my head, I can think of 3 pretty good ones. So one is you are running on bare metal in your own data center, and you don't have access to fully managed alternatives to databases like RDS, Elasticache, Redis and Memcache, et cetera, et cetera. So that's one use case. Hey, you have this platform, why not use it to run your database? 2 is you need short-lived databases. And that is like you're deploying your apps to Kubernetes as part of preview environments or like Heroku review apps or these short-lived environments. And spinning up infrastructure for a preview environment is overkill. It's like using a bazooka when you needed a BB gun. It also takes a lot of time. Like provisioning an RDS database might take you 15, 20 plus minutes, and deploying a container takes you like 200 milliseconds. So that's a strong argument to be doing. 3, the third argument is cost. And I think we need to be careful here what cost means. When Cloud Posse got started in 2015, my whole vision was, hey, there's so much open source to do everything we're paying all these SaaS companies for, and we have Kubernetes. Why don't we achieve, this is my hypothesis at the time, greater economies of scale by just deploying all of this open source onto our platform? So for APM, we were deploying Sentry. For monitoring, it was Prometheus or Grafana. For Elasticsearch, for logging, it was Elasticsearch. And it goes on and on and on and on. And we were deploying a huge stack on top of Kubernetes. And the great news is there were no more vendor agreements that had to be signed, and the licensing costs went to 0. But the overhead skyrocketed, and the tech debt became insurmountable for the smaller companies that don't have dedicated teams. Look, the companies that operate things like Prometheus and Grafana at scale, or like actually operate it, have teams dedicated just to managing those things. And the teams that say they do it but are just deploying a Helm chart just haven't been doing it long enough to learn why they don't want to do it anymore. Because once you get to one of those major upgrades, it's gnarly, and you're terrified of losing any data, so you don't upgrade and you stay behind just because you're afraid of breaking anything. So when it comes to running your databases on Kubernetes, and when I say you might know you're doing it for cost reasons, it's not because you don't want to pay a SaaS provider necessarily. It's because you need to run 10,000 databases because you're a WordPress hosting company, and running 10,000 RDS databases would be ridiculous. Or you're limited on just kind of some of the ways you could use maybe RDS, or your company for some reason leverages some proprietary Postgres plugin, and you can't install that on RDS, so you have to run your own database. So that would be the other scenario that I think about. So how do you do it? Well, for those short-lived preview environments, for the short-lived databases, we're not talking like day 2 operations. We don't need backups. We don't need restores. We don't need high availability. We don't need to worry about any of that stuff. Dude, just use that Helm chart we were talking about earlier. Just deploy it with Helm. It'll come up real easily. The architecture and best practices are managed by the community. However, if you are now concerned with how you're going to actually manage day 2 operations for that database, this is backups and restores, this is automatic failover, this is upgrades. This is where the concept of operators come in. So if you're just using raw Helm, you are the operator, the human. But if you want to have this programmatically managed for you a little bit more, you can use an operator. And I can't speak from firsthand experience because we basically do not recommend to our customers for anything mission critical to use Kubernetes for it. Not because Kubernetes is the problem. I wouldn't recommend you to do it on your bare VMs, on your bare EC2s for the same reason, but just because it's complicated. So there is a company called kubedb that specializes in this, and they have an operator for every major database out there. And what's nice about this is it adds commercial support if you want it. So they're open source with commercial support. The problem with operators Like, this has come up before. Like, the best explanation is Helm issues, CRD. We talked. I'm not going to find it in time, but there's a long write-up by the Helm community on just like why custom resources are great, but then like why they suck a lot. And the problem with custom resources is if you delete the operator for the custom resource, every resource that it manages is also deleted. That kind of sucks when it's your database. When you are running a custom operator, yeah, it's versioned, and you cannot today run two versions of that operator concurrently. So it's kind of like, hey, this is your control plane for all of your databases. Your whole business depends on it, and you're going to go upgrade this operator, and you really don't know what the outcome of that's going to be. And worst case, it's totally hosed. You can't even delete it, because if you delete it, it just deleted all your databases. So you are cornered in to being a pretty hardcore Kubernetes admin if you're really going to be managing operators at a production scale for mission critical applications where everything's on the line. So this is my biggest problem, is that a lot of people get started with Kubernetes, a lot of people get started deploying these things, and it's so freaking easy, but they don't realize what the day two operations are along with that. So maybe that's why it's also good to go with a company like kubedb, not speaking from experience, or it is not an endorsement, but somebody who's going to provide you support on that might not be a bad idea. There's also something called Operator Hub, which provides a directory kind of like the Terraform registry. And this was also recommended here. You can filter for operators on a lot of the databases out there. But dude, when you check out these operators, look at like the commit history, the activity. It seems like operators are like, everybody who wants to learn Golang, this is like one class of weekend projects. Hey, I'm going to write an operator for deploying MySQL databases. So you'll find a lot of operators that were created over a weekend and then never touched again. So what is my recommendation with all that said? Yeah, just try and use managed services as much as you can, and then use Helm for the things that you don't care about, and operators last if you absolutely need something to manage the life cycle.